Hello friends, it's Jordy here and welcome back to my YouTube video series using RStudio. I made a post on Facebook a few days ago that I want to make a video about Boxplots, and this is the video for that. So I find Boxplots very useful for a couple of reasons. The first one is that you plot the raw data in a boxplot. You can also plot the raw data in a scatter plot. In contrast to needing to calculate a group by summary of the means to plot in a graph with error bars, you can just use a box plot on the raw data. And that's one reason. The other reason is that you can show a lot of useful information within a box plot. Okay, so by default, the middle line in a box plot will show the median will show the median value. And you also get the interquartile ranges with the boxes and the whiskers, and you also get outliers, which will be the circles in a default ggplot graph. So already you see a lot of information which is very useful, that we would call summary statistics. You can also add nice colors and use facet wrap and do things that you can do in other graph types as well. But it's quite simple to make a box plot, especially with ggplot, and that's what I recommend people start with when they're learning to make graphs. As I said, a scatter plot is another one that can be very useful because you actually plot the individual data points. You could use gm_jitter within a scatter plot to prevent overlapping. So these are really good graphs to start with. In terms of data sets, let's use one in the faraway library today, okay? So I made an R script, right, with notes on every single data frame that is available in the faraway package. If you want this, just message me below and I'll send it to you. There's a lot of data frames here, and I think I've mentioned before that they cover a wide range of subjects, okay? Doctor visits in Australia, a French presidential election. But I kind of got interested in this one, which is called Fortune, and that's billionaires, wealth and age, okay? So maybe this is just wishful thinking, but I wanted to show you guys that I'm not only working on data sets about animals and plankton, even though those are probably my favorite types of data sets to work with. I might also work on economic data, wealth data, societal data as well. Alright, let's load the library that we're going to need, which is faraway, and you should have this already because this was one that we used for a previous data frame called Gala. Okay, so that's now good to go. Then you can just type in view the name of the data frame. It's called Fortune, but it contains data on billionaires. Okay. Before we talk a little bit about this data, do you notice that there's been a new upgrade, a new version of RStudio? And in that new version of RStudio, this little thing's been added whenever you view a data frame. Okay, so a summary is being included, and I'm not entirely sure how I feel about this, but it could be useful because actually just clicking on each column's name now, we get useful information about the column. Okay. I'm not seeing missing data though. I'm not seeing if there's any missing data. In general, I think it's useful for means and stuff, but it's not a mean for a particular group of region or anything, and it's not like a mean wealth for a different level, different levels of region. And also, I think it kind of gets in the way a little bit. You know, I would prefer that this took up more space than having this in the side. And I'm going to use other code for calculating summaries anyway. But looking at the data frame, it's nice because there's only 3 columns. 3 total columns, 232 rows. That's a nice size data set to make a graph with. You've got 1 column on wealth, you've got 1 column on age of individuals. So there's a row for, each row is for a single individual. And then there's different regions here which are coded according to various letters. As you know by now, we're not going to get that much information from the column titles in these data frames, which is a shame. And I would probably recommend, if you have your own data frame, that you add more information to the column titles. Oh, I also see that you can pin these now. That's pretty cool. So pinning it would mean that that would stay showing even if you scrolled left and right to other columns. Oh, that's quite kind of useful, especially if you've got a really wide data frame to pin one column. All these little tweaks that are being made consistently to RStudio are pretty cool. So what I would probably do with summary statistics is load a library called skimr. And I like this a little bit better than that little approach that we saw there being added to RStudio. Then if you use skim fortune, okay, simple, just like str fortune will tell us information too. We get this pretty useful summary within the console about each column. It's going to tell you the types, so how many columns are factors, how many are numeric. Okay, so that's probably, yep, this one here will be the ones with letters in, okay, this region, and then these two, wealth and age, are currently numeric. Scrolling down, if we look at each one of these data types, firstly, the factor column, there's no missing data here, right? So there's no n missing is 0, and that means there's no missing data. When we look at these numeric columns, which are wealth and age, we also get this little histogram below, but that's not particularly useful, I think, for now. Maybe it's kind of like a quick little, thumbnail glance, but if I was wanted to make a histogram of this, I'd make it a lot bigger. This n missing shows that we've got 0 rows in the wealth column that are missing, but we have 7 rows in the age column with missing values. So seven rows, 7 individuals do not have an age, showing for them. You're gonna now want to figure out, who those rows are, who those individuals are, and a useful way to do that is using a library called naniar. Yeah. I've noticed over time I've really adopted a kind of visual method of looking at things like missing values, and in combination with another library called plotly, we can actually make a graph to figure out which rows in the age column are missing. So I'll show you how that's going to work, okay? Let me just separate this into view data and summary stats. Find out the rows with missing ages. So if you've got naniar up and running, you just need to do this, right? This miss. Like this. Fortune. Alright, so we're nowhere near the Boxplot stage yet, but here's a graph. Okay. Right, so if you just type it like this, you can't really interact with the graph or anything, but these lines correspond to the missings, okay? The blacks are the missing values. However, we can make this much more interactive and easier to work with, having loaded plotly by typing ggplot2 in front of the this miss part. Okay, make sure you've got closing pink bracket at the end. This is the importance of using rainbow parenthesis in RStudio, because you make sure, at least in this color scheme, that the first and last in every sentence of code, every row of code, is pink. Then you won't get an error. Alright, now I've turned this into a plotly graph. and it might take a second to load because it does some, it makes the graph much better. So here we have an updated graph. It's already moved the column titles, which were previously up here, down to the bottom, so that's one change. In addition to that, you can scroll through the black lines, again corresponding to the missing data, right? So true missing, i.e. missing. And when it goes black, you can find the row number, okay? We're looking in the age column, of course, right? You know that this is a column that has a missing data from the previous skim, but also because these other ones say 0%, which means that there's no missing data. This one has 3% of the data are missing in that column. Again, we scroll over them and you see it goes black for rows 104, okay, and 132, etc. So let's just go back to the original data frame and have a quick look and make sure that that's right. Okay, these correspond to the row numbers shown here. 104 says any next to age, etc, etc. So one thing you can do is you can make a new data frame with those rows taken out for 7 values. Probably going to do that. Okay, copy fortune and delete missing. You can use dplyr for this, or you can just use old school base R code, and I find myself weaning off of old school base R code for things like as.factor, as.numeric now, because you can do it within dplyr, but I'm still using this. I'm still using any omit. So let's make a copy. Fortune2 is based on fortune, and then it's just a simple case of putting any omit in front of it. This method will delete all rows with any missing values, so it's going to delete 7 rows here. There's another way to deal with NAs, which is any.rm. I might talk about missing data in another video. Okay, now you remember that the original fortune had 232, and this should now have 225. $225, great. No NAs should be shown here. If we did a this mess of this one, I'm expecting all of these to say 0% now. Alright, so then we'll just confirm the data types using str, just because it's a nice little thing to do as well. Once this is finished showing, 0, 0, 0, great. So str fortune2. Alright, we've got num, int, and factor. Okay, so this would be pretty good for a box plot. What we can do is we can plot wealth on the y-axis and region on the x-axis. Let's start with that. Okay, I might do another thing in a second after showing one graph, which is to create a new column, put in the ages together with case_when into age groups. And I find myself doing this a lot these days. A new variable that puts countries, for example, into continents, or puts ages into age groups, or puts heights into height groups, or puts animals into a major type of animal, you know, like a carnivore or a herbivore, etc. So it would be useful. We could then turn that age group into a factor as well. But let's make initial box plot of wealth versus region. Alright guys, so I'm not going to name this graph because the only times you really need to name graphs are when you want to put the graphs together for the purpose of patchwork, mostly. So just going to start off with ggplot. You guys will know how to do a ggplot by this point. But if you don't, it always starts with the first line showing the data, the name of the data, x-axis and the y-axis, okay? So the x-axis is the region here, the independent variable. The y-axis is wealth, the dependent variable, aka predictor, aka response. gm_boxplot. Alright, let's see what happens if you do this. Okay, so because region is coded as a factor, this worked very well already. You might find some situations if you try and use an x-axis as not a factor where it has problems with grouping. I generally think that can be solved by turning the x-axis into a factor, because now we have box plots for each individual region, A, E, M, O, U. We have wealth shown on the y-axis. As mentioned before, you've got these individual boxes, and you've got flat horizontal lines in each one that correspond to the medians. These circles here are the outliers, and the boxes are the interquartile ranges. Okay. It looks like, firstly, there are quite a few outliers. So we already removed some rows for missing data. There might be a reason to remove outlying data points, but I won't for now. That's a whole different subject. Again, we can find out more information by putting ggplotly in front of it, which allows, in front of all of it, just like we did for this miss. Don't forget your pinks. And that will allow us to interact with the graph by scrolling over the points. Alright, so this one, some individual, some person, some big roller, high roller, was making 37. Okay, much higher than anybody else in region M. This is probably a great opportunity to go to the internet and find out more about the data frame, which, guys, I should have already done in this video, but I didn't. Billionaires faraway library. Okay, fortune faraway library. You are likely referring to the famous fortune dataset in the faraway R package, which is widely used in academic statistics and data science exercises. The fortune dataset contains records for 232 of the world's billionaires, as published by Fortune magazine in 1992. Oh, that's why it's called Fortune. Is a classic dataset used to teach data transformations. Okay, so we haven't really analysed it yet, but it seems like the data with a histogram will be heavily right skewed. We can do that in a second. And so this is the data frame for people that want to try to do log transformation of the wealth column. Okay. The regions are, I think this is important actually, to make sense of the letters. Europe, Asia, Middle East, United States, and other. Okay, that's probably useful to stick that information in here. Okay. Yeah. A is Asia. E is Europe. The graph is showing them in this order because this is the default order for an x-axis is alphabetical. Okay. Yeah, in this case, United States comes after O. So O is showing first. You can order this again by using level and when you define factors and just set them yourself. Or you can do it in the graph as well. So based on that information, and one other piece of information, what are the units? Okay, wealth in billions of US dollars. All right, we've got everything we need now. Wealth units, billions of US dollars. So then we know that this there's someone in the Middle East that's like making bank. Okay, 37 billion. Now, of course, I'm not happy with the graph right now because it doesn't have the labels as they should be. So let's call X region with a capital R. Let's call Y axis wealth and give the units. Billions USD. Guys, I've added the labels, I've coded for the labels, region and wealth billions dollars. I'm going to take the plotly part out now, just because the further customizations I want to do, you know, using typical ggplot without this kind of style here, which is really useful for data exploration. As I said, I'm using this and plotly to find out about things like missing data, and also look at what it shows when you highlight a box plot. It tells you the medians here as well. Okay, so it's really useful for overview of data, but for the purpose of making a really nice pretty graph, I'm going to go back to ggplot. Alright, plus it's faster to load. Okay, so what am I doing wrong here? I've got an extra bracket in that, so we don't want the extra bracket. This goes back to ggplot, and don't forget to, you know, finish off your units with a bracket. So this is a bit better now. We can do theme lines, as you know, theme underscore classic, theme underscore Cleveland, to make the graph look a little bit nicer in general without too much more. I don't really like too many of the built-in ones, okay? So I load another library, which is called ggpubr, and other ones as well. There's a really great one. What's it called? I can't remember the name of it, but it's actually really nice for different fonts and stuff like this. Then we can use, once that's loaded, theme underscore pubr. Okay, I'm gonna put base underscore size equals 12 here, and that will change the size of all the text, or most of the text on the graph. Sometimes not all of it. Okay, great. So it's looking a bit better. This point in general is kind of messing up a lot about the graph because it's pushing everything else down. Again, we could take that one out. But for now, let's proceed. Actually, no, let's take him out. Let's take him out for now. Or her. I'm sorry, I didn't mean any bias there. We don't know who that is. If you know who that is, you know, tell them that if they need data analysis help. Okay, it's this one here, the 37. And we're going to remove the major outlier, just for the purpose of helping to understand Boxplots better. Like I said, be careful just taking out data points. They might be there for a reason. I mean, they could be there for a reason. They should be very, you know, you should be very careful about taking out outliers and taking out data points just to make things look nicer or fit your data. This individual that's made all that 37 million, we are just going to make a copy of Fortune 2, call it Fortune 3, and use the old base R method to remove rows. You can also use this to remove columns using square brackets. To remove that row, which is, okay, just happens to be number 1, you have to put -1 and then a comma at the end. If you don't put a comma, it will take out the first column. Okay, so what I would do is take out the wealth column, which we can't have that because we need that for the graph. So we want to take out the first row and we use -1 comma. If you wanted to take out multiple rows, you do C. You use C to specify multiple rows that you want to remove. All right. Now we're going to view the fortune free. And it's been taken out. Now what we want to do is copy the plot from before and run it again for the fortune free data frame instead of the fortune 2 one. And I'll take out the ggplotly part. Make sure all my brackets are good, they look good. Switch that up. Fortune free contains all the rows apart from this one here. Okay. This is called second Boxplot. So interestingly, it looks like from what I'm seeing here that the medians are kind of similar between these different regions of wealth in billions US dollars. Okay, amongst the richest people, world's billionaires. What could we do now? Okay, this is probably a good opportunity to add color to the graph. Again, if you just want everything to be, or all your boxes to be single color, you generally do that within the geom line, okay? If you're trying to color code by a specific third variable, another column, I would do that in this line up here, okay? So in that case, it would be fill equals in this line. Okay, but instead you can do something like this. Call equals blue. When you start, so we're just coding everything for one color here. When you start typing quotation marks and then a real color, blue, red, orange, etc., it's going to change color, this text, to that color. Okay, so notice that call is for the outside of the lines. We can do fill and that will do the middle, that will do the boxes. Okay, so call does the lines and the medians and fill in a box plot does the inside. Let's do green for, you know, these guys have made a lot of green. These people. Okay, so it's looking a little bit nicer already. What I would like to do at this point is add statistical results that will compare the rank comparison with a Kruskal-Wallis Duns test. And that is one of the most appropriate tests that you could run when you're showing a box plot, because it actually is kind of like comparing the medians instead of comparing the means in an analysis of variance. So these lines show the medians anyway. So it would actually really help to put the Duns test pairwise comparisons onto this graph. I did this before in a previous session using ggsimplestats. Okay, and it's going to be very, very difficult to remember the code for this one, but it's something like this. That's it. Stat kw all pairs Duns test. Done test. So we just add that on top, we run it again, and if there had been any regions with significant differences in wealth at a p-value less than 0.05 by default, it would be showing lines between the different boxes, and it's not. So there isn't anything. There's no significant differences for wealth in billions between the regions. I'll just show you what another case would look like where you do have significant different pairs. Diff pairs, let's just go back to the old school empty cars. I mean, whilst it's not my favorite data frame, it's probably the data frame I use the most. PG, let's make this one purple. And what I'm doing here is I know that we can plot miles per gallon on the y-axis and cylinder on the x-axis, and we can put we actually don't really need labels for the purpose of this, so I'm going to delete that line for now. This is just to show you a case where there would be significant differences. In this case, the miles per gallon varies between cylinders. Okay, now this is very, very important. This actually draws attention to a situation when the cyl being numeric has caused a problem. It hasn't actually shown box plots for each individual cylinder. You want to have the x-axis as a factor. And if you haven't done it already, you can do it here in the graph code. Because if you then put factor in front of cyl, it will show 3 boxes. Here we have this one square line which draws, it says that there has a significantly different miles per gallon between 4 and 8. Okay, and the p-value is less than 0.001, much lower than 0.05, which is the threshold, aka the alpha p-value. There's only that one case drawn there, significantly different. There's no significant difference between this box and this box, or this box and this box. So that's pretty cool. Now let's go back to a third box plot, and in this third box plot I would like to take the colors out here so they're not all uniform colors, and I'd like to have a color variable in here. The only problem is we don't really have anything to use as a color variable right now. I'm wanting to turn age into that color variable, but right now it's all single years and hence it's being treated as numeric. I'm thinking we could create a grouping variable of this. We know that the age is, oh wow, there's a 7-year-old. All right, there's a 7-year-old billionaire from Europe to 102. Okay, so we're going to take these ages and put them into groups, you know, ABC, from smallest to the highest. Okay, so remember, if we want to make a new variable, we use dplyr, and moreover, we use the mutate function. I'm going to make a copy of the fortune 3 and call it fortune 4. And then we're going to use the pipe function. Of course, for the pipe function to work, we need to have tidyverse running. I've already got it running. Incidentally, I wouldn't have been able to do ggplot if I hadn't, but don't forget it. Don't forget it. And put them in a place in all the libraries you're going to use right at the top, so it's clear that you've got to run them first. Okay. Mutate. Okay, I'll put this now before case when. Okay. We're going to call this age underscore group. That's the column you want to create. The new column is going to be called age group. That goes directly after the brackets. Equals case when. Case when what? Let's make objects, right? That we're going to say if the age is in this group, we put A. If the age is in this group, we put B. So I'm just going to put age group 1 is 1 to 10. Alright, I'm just going to copy this a few times. It might save a little bit of time because we've got to go all the way up to 102. And nice for these guys, huh? Nice for these guys to have billions. But I don't think money can buy you happiness. But coding can, right guys? Let me know in the comments below whilst I'm doing this what projects you're working on, please. I'm curious. And I'm also curious if any of this stuff has been able to help you in your own projects. So actually, let's just code these by 20s, okay? So that would be like that. This would start at 41 and then go to 60. This would start at 61 and go to 80. This would start at 81 and it would go to 100. And then we're kind of close to the last ages, which are 101 to 102. Okay, 1, 2, 3, 4, 5, 6. We've got 6 age groups. We'll tell R that that's what we want our age groups to be, and it will remember it. Okay, and here, this is when we start with the actual, like, assigning ages, you know, well, assigning new values to the new column. Okay, so making the groups in the new column. Put in the age group. Case when, i.e. if age group 1 percentage in percentage age, then squiggly line A. Okay, and I'm calling it A. We could also call it 1 for those individuals between 1 and 20. It's up to you. If you're going to use letters, put the letters in quotation marks. Okay, now we have a problem here. It said failed to evaluate. Ah, I know why it is. It's just I accidentally wrote it round the wrong way. It's this way. That's it. So the column that contains the original data is written first, and then percentage in percentage, and then the object that contains a target that you assigned here. So it's looking for these ages, and if so, it puts A. Alright, let's do a view of the fortune 4 now, and then we'll repeat that for the other columns. Okay, so great. So now there's an A here next to 9. Okay guys, so that's the first group done. Okay, so the individuals aged between 1 and 20 have been assigned to age group A in the new column, which is called age group. What you've got to do now is you've just got to copy the stuff in the oranges here. Okay, so we haven't finished, which is why I haven't put a pink bracket. We are going to continue this. We're just going to copy the stuff in the orange brackets and paste it again several times. Okay, you can put these onto new lines. Just make sure that you put commas at the end of each one. Don't worry about the letters being the same for now. I will fix that in a second, because we need obviously a different letter for each age group. These different letters will give us A to F. Okay, make sure we have 6 here, a letter for each age group. That's 6 now. Let's put B, start with the letters, C, D, E, and the F age group. I'm putting the pink bracket in there so we can close it. I like putting age groups on different lines, or my different groups in different lines, just so I can clearly see them better, make more sense of them, see them more clearly. Alright, all of these currently say age group 1, and that's not correct. These need to be updated for the different age ranges. So we've got to cover all age groups. Okay. Alright, so what that means is
The 1s to 20s are A, the 21 to 40 years old is B, 41 to 60 years old is C, 61 to 80, that's D, and 81 to 100, that's group E. Finally, 101 to 102, grey age, that's going to be group F. Let's see if it worked, guys. Okay, there's no errors anyway, which is always a good sign. And we're going to view fortune 4. Nice. Look at this. I'm scrolling all the way down to row 224. And there's no blanks, there's no missing, there's no problem. Quick check of the fortune 4. Why did it do that? Fortune 4 will tell us the data types. I'm interested in if this is a factor. It's not. It's not by default, it's a character right now. So we want to turn that into a factor. It makes it easier to work with, like we did with cylinder, like we did with region. Factor, it's easier to work with if you turn it into a factor. We could use the method that we used previously for factors. We could either put it in ggplot, or we could code within old school base R codes, or we can use dplyr. And to use dplyr, since we're already using it, you're just going to write the same thing again in a separate line. Just overwrite what it originally is. Something like this. And then run the str again, and we'll check that it now says factor. And it does. Look, its age group is now a factor. Great, guys. So we're rolling with gas. We're rolling with gas. And the ultimate goal is to make different facets for the different age groups. So let's take this code here and make a facet box plot. Again, we don't have to change too much. Well, we have a couple of options. We could either use facets, or we could use fill for color, to color the points. Let's start with color the points, because I've already started writing that. Let's do it here though. This is going to be age group, but we're referring to fortune 4 now, and we're going to put fill equals age group in the first line, not in the box plot line. Okay, so that gives a graph that looks a little bit clumsy. We do have regions on the x-axis, and we have all these different age groups, but it produces potentially too many box plots in a single graph. So that's why in this case we can leave the colors for the age groups, but let's facet wrap it by age groups to separate them into different panels instead of being all in the same panel. Okay, so the reason why I did that is because I put age dot group instead of age underscore group, which wasn't the name, and this is. Okay, so this is nice, because now we start to see some statistically significant differences according to the Dunn's p-values, especially for group C, age group C. The last thing I wanted to do is potentially use a library which is called ggh4x, and this has a little thing in it called facet underscore nested. And if you do this vars, so instead of just doing squiggly line like you did in facet underscore wrap, you do vars age dot
age underscore group. Let's see if anything changes. Okay, it's moved them over here instead of along the top. The graph doesn't look much nicer like this. It can look nice for other types of graphs if you're interested in it, but it does give you the option to show the titles or different values for the age group on the side instead of along the top. For now, I'll go back to the original, but this script will remain available for you to contact me and get that way. Facet underscore wrap. Alright, and then there's one last thing I want to do. Which is, hang on a second. Once this is finally running, it needs to have that squiggly line there. The last thing I want to do is show the means as well, because the means are not showing on this. Only the medians, which are the middle lines. As I said, I do like to put lots of information into a graph. You might have a different preference, but you can do this, right, without having to calculate them yourself. In a separate data frame using group by summarize. You can actually do it directly in ggplot. And the way that you do it is you start typing stat underscore summary. Ignore everything else here and take the bottom one. Okay, now you need to say fun.y equals mean. Okay, geom equals, I think you've got to put this in quotation marks, point. And you've got to do a color here. So let's do a color as red, because we haven't used that color already. Yeah, and now the red dots have been placed on top of this as well. Let's just check, because I sometimes always get confused with quotation marks, especially in ggplot. Let's see if it would still work here. Yep, that worked as well. So I would zoom into this, and guys, we've definitely got a pretty good understanding of the wealth. Apart from that one person that had 37 billion in the Middle East, you've got most of them are less than about 20 billion. This one's got 25. I'd probably say most of them are less than 10 billion. And for every age group except for C, okay, which is kind of like middle-aged, there's no significant differences between regions, but there is for group C. What's group C? We have a difference between this A and M, and a difference between M and U. And that's this one's here. Group C corresponded to group 3, 41 to 60. Quick recap. This M had a 37. You're sorting by age. We saw that there was a 7-year-old with 1.5 billion. There was 102 with 2 billion. And then we did further checks to separate into age groups, and then there was statistically significant differences for group C, okay, between different locations. So guys, I hope that was beneficial to you. If it was, please leave a comment. Please tell me data frames that I should continue to work with. So far we've done empty cars, empty cars, empty cars, no, diamonds, iris, plankton, gala, this, mammal sleep. So if you know some other nice ones, let me know. Let me know what you'd like to see next, and please subscribe and share.